In the last example, we used the elimination method to solve 2x minus 3y equals 7 and 2x minus 2y equals 6. We were lucky because when we subtracted blue from red on the left, we had 2x minus 2x, which is 0x. This is how we got an equation with just one variable y, which we could solve. But what if we're not so lucky? Let's look at the example where we find the solution to the system of equations 2x minus 3y equals negative 11 and 3x plus 2y equals 3. Here, if we subtract the left-hand sides, we get 2x minus 3y minus 3x plus 2y. 2x minus 3x is negative x, and negative 3y minus 2y is negative 5y. This is not helpful because it did not eliminate a variable. That is, we didn't get an equation with only one variable, which is what we wanted. Why did this work in the last example, but not this one? Well, in the last example, the coefficients of x were the same, so they subtracted to 0. How can we get that here? The trick to eliminate x is to multiply both sides of each equation by the coefficient of x from the other equation. In this example, we would multiply the top equation by 3, and we would multiply the bottom equation by 2. In the top equation, this simplifies to 6x minus 9y once we distribute the 3, and negative 33 on the right. In the bottom equation, the left-hand side becomes 6x plus 4y when we distribute the 2, and 6 on the right-hand side. By multiplying the first equation by 3 and the second equation by 2, we got the equivalent system 6x minus 9y equals negative 33, and 6x plus 4y equals 6. The reason we made this change is so that when we do red minus blue, we have 6x minus 9y minus 6x plus 4y equals negative 33 minus 6. Now on the left, we have 6x minus 6x, which is 0, and negative 9y minus 4y is negative 13. On the right, we have negative 39. So we have an equation with just one variable y, which is negative 13y equals negative 39, which we are able to solve. We can solve it by dividing both sides by negative 13 to get y equals 3. Now that we've solved to find y equals 3, we can substitute it in any equation with x to solve for x as well. Using the first equation, we get 2x minus 3 times y, which is 3, equals negative 11, which is 2x minus 9 equals negative 11. So adding 9 to both sides gives 2x equals negative 2, and dividing by 2 gives x equals negative 1. So we can conclude that negative 1, 3 is the solution to the system of equations.